All right, so on the back side of day 8 notes, we have just some extra practice on solving for a side and solving for an angle, since we will have an assessment coming up. Just to review and make sure that we know how to do both. All right, so this really has nothing to do with what we were doing on the front side. Okay, so in number 13, we can realize that we are reading from the 32-degree angle, that x is our opposite, that 15 is our hypotenuse, and we have some old horse caught another horse taking oats away. All right, and our directions up here say we are going to round our answer to the nearest tenth for whatever we are solving for, whether it's a side or an angle. All right, and so in this first one, we're going to be using our sine trig function, since sine theta is equal to our opposite over our hypotenuse. Okay? Remember, we replace our three pieces. So we're going to say sine of 32 degrees is equal to our opposite side over our hypotenuse side. Okay? Now, we are solving for a side. So if you remember, that's the cross multiply one. Okay, so we put the left side over 1 so that we can cross multiply and end up with x equals 15 times the sine of 32 degrees. Okay? Because we have x equals, type it in our calculator, and we end up with 7.9487. 7.9487, ... Directions say nearest tenth, which is the first decimal place, and we end up with x equals 7.9. Okay. All right, number 14. We are reading from angle x, therefore 12.5 is my opposite, and 15 is across from the right angle, so hypotenuse. Okay? And again, we'll be using the sine trig function, so we'll go ahead and say sine theta equals O over h. Sine of x equals 12.5 over 15. Okay? But this one, guys, we're solving for an angle, so I was almost tempted to cross multiply, but that's going to get you stuck. All right, so remember, when you solve for an angle, you bring the angle out. Okay, so x equals sine inverse has to be used to solve for the angle, 12.5 over 15. All right, second sine to get the inverse in your calculator, type in your fraction of 12.5 divided by 15. And you end up with 56.44269, ... Directions up top say nearest tenth, so underline the first decimal, look at the next. And we can go ahead and say that our answer is x equals 56.4 degrees. Okay. All right, guys, let's take a look at 15. We are reading from angle x. 12 is the opposite side. 18 is my adjacent side. And according to SOHCAHTOA, we'll be using tangent. So we'll go ahead and say tangent theta equals O over A. We'll keep tangent tangent. Our theta is x, our opposite is 12, and our adjacent is 18. Again, we're solving for an angle just like in the last one, so we have to bring the angle out in front and say that it's equal to the tangent inverse of 12/18. Hit second tangent in your calculator to get the inverse of tangent, and then type in 12 divided by 18 and hit enter. You guys should end up with 33.69006 ... And directions say nearest tenth, so we underline the 6, which is the first decimal place, and look next door. And then we can say our answer is x equals 33.7, and this is an angle, so degrees. Okay. 16. Again, we're reading from 43-degree angle. X is across from our right angle, so it's our hypotenuse side, and 10 is our adjacent side. A and h is cosine, so we say cosine theta equals A over h. Cosine, theta is our angle, which is 43 degrees. Adjacent is 10, hypotenuse is x. And we are solving for a side this time, and that's the one where we put the left side over 1 and cross multiply. And we're going to end up with 10 equals x times the cosine of 43 degrees. And you'll notice that x, we didn't get x equals. So we have to undo the multiplication that we see here with division. Okay? And we're going to divide by the cosine of 43 so that these cancel, leaving me with only an x on this side. And in my calculator, I'm going to type in 10 divided by cosine of 43. And we end up with 13.673 2 dot dot dot. Directions say nearest tenth, which is the first decimal. Look next door. And now we can say x equals 13.7. And that's a side, so no degree symbol. Okay. All right, guys. One last question down here at the bottom. Talks about Sam. Sam is holding his kite string 4 feet above the ground, as shown in the accompanied diagram. The distance between his hand and a point directly under the kite is 105 feet. All right, so that's in our diagram, so we don't have to wonder where that is. And they talk about the angle of elevation, and that's something we're going to start talking about. In this one, you don't really need to know where the angle of elevation is because they put the 65 degrees in our picture. But we're going to start talking about angle of elevation and angle of depression on the next day. Angle of elevation is how much you have to look up to see something. Okay, that's up in the air. So because the kite's up in the air, when Sam here looks straight out, okay, and then he all of a sudden looks up to see his kite, he's looking up 65 degrees. All right. And we're going to find the height of his kite to the nearest foot. Okay. If you take a look at the height labeled in the diagram here, that's from the kite all the way to the ground. But you can see that our right triangle doesn't go all the way to the ground. So we're going to have to be careful. In this right triangle, what we're going to do is we're going to solve for this piece here. Okay. That goes from the kite to the right angle. All right. If we want to go all the way to the ground, we have to realize that we're going to take that height and we're going to just add 4 to it. All right. So we have to remember that at the bottom there. Okay. Because this little piece extra is 4 more feet. All right. So we'll use Sam as our stick person. He's already standing at our angle that we're reading from. And again, we're solving for this piece over here, which is the opposite side. And we have the 105 on the bottom, which is our adjacent side. Okay, so we're going to be using tangent theta equals O over A. Keep tangent, tangent. Theta becomes 65 degrees. Opposite is what we're solving for. So we call it X, and adjacent is our 105. Because we're solving for a side, this is the one where we cross multiply. So I put this over 1, and we end up with X equals 105 times the tangent of 65. Okay. We type that into our calculator. And we end up with 225.1732 dot, dot, dot. But remember, that's not our answer. We had to add 4 to it. So we'll add 4 to it, and we end up with 229.1732 dot, dot, dot. Okay. And now we can go back up and say, oh, yeah, nearest foot. So the 9, but look at the 1, and it won't move. And so we'll say that our height here of our kite is equal to 229 feet. Okay. All right, so part B says find to the nearest foot how much string extends from Sam's hand to the kite. So from Sam's hand is right here, to the kite is right there. And so that green line is representing the string, okay, that the kite is attached to. And so we want to figure out how much that is now. So I'm going to go ahead and call that Y, since I already called our opposite side there X. I could use the Pythagorean theorem since we now have 2 sides of our right triangle known, but I'm going to go ahead and make sure that we are practicing our trig instead. So we're going to go ahead and say that we're solving for the hypotenuse side, and I'm going to still use our adjacent side here with the 105. Okay. Sometimes if your picture does get a little complicated, guys, you can always redraw it if there's too much going on so that you can just label the pieces that you need. All right, so for instance, something like this, where I'm reading from the 65, I need the 105, who's my adjacent, and then I need my Y, the side I'm solving for, which is my hypotenuse. And so now I can see a little bit clearer that I'm using cosine. Theta equals A over H. Keep cosine, replace theta with 65 degrees. Adjacent is 105, and X is Y. Okay. We are still solving for a side, so we're still going to cross multiply. And we end up with 105 equal to Y times the cosine of 65. We're going to have to divide by the cosine of 65 so that Y becomes by itself on the right-hand side here. And type it in. 105 divided by cosine of 65. And we end up with 248.45 1, 1, dot, dot, dot. Directions said nearest foot again. So we'll underline the 8, look at the 4. And we're going to go ahead and say that that length is 248 feet. All right. And then we are finished with that. All right. I will see you guys on day 9 notes in order to talk about angle of elevation and angle of depression. All right. Bye, guys.